So, the diagram shows a sketch of f of x. On the same diagram, sketch the curve f of x minus 3. When it's outside, what does it do?
The opposite.
X and Y.
No, that's inside.
Do you know? You tell me.
Is that what you think's going to happen?
It does what you think's going to happen. It's moving up or moving down. It's what you think's going to happen. So minus 3, it's moving down 3 places. Now, if you read carefully, it says mark clearly the coordinates of the points where it crosses the y-axis. So this 3 and this 3, or the minus 3 and the 3, irrelevant. Okay, we don't know what that's going to be. When I move that down, I don't know. Okay, so that would look something like that. Okay, and it's going to be going through minus 12. Okay. The one underneath, what's going on here when it's inside?
The opposite what you expect.
Opposite what you expect, and instead of going up or down, it's going left or right, okay? So you assume it's going to the right, it is not, it's actually going to the left. It's doing the opposite of what you expect, so you go back 3 places. So if you go back 3 places from 3, then you're going to be going through the origin, aren't you? Okay, so make sure it does go through the origin. That minus line, you've got no idea where it's going to cross now. The other thing you've got to be careful with, it says here, mark clearly the coordinates of the points where it crosses the x-axis. So can you see they don't really care about the y-axis. So this must be minus 6, and the curve should look identical, but just moved along. Okay, something like that. Okay. Now it says here, state the minimum value of y equals f of x plus 3. Any idea what that means? If I looked at that, I wouldn't say that's the minimum value. Where's your gut feeling of minimum values?
The very bottom.
At the very bottom, that's my gut feeling. That's where a minimum is going to be, isn't it? Okay, and that is what we do call the minimum value. Okay, so a maximum value we can't have because, any ideas why?
This is 2 points.
Excellent, 2 points. They're both shooting off to infinity. So the maximum value, this would be infinity times 2. It would be 1 infinity in the negatives and 1 infinity in the positives. You could have a maximum value if it was an n-shaped graph. Then you'd have a maximum point. Excellent question, well done. So the minimum value is minus 9, or you could give the coordinates of that. So that was 0 minus 9. It now must be minus 3 minus 9. Happy with that?
Yeah.
Bit sneaky for that one mark. It's like I said, people go out and say, oh, the transformation of the graph was horrible. It's like, okay, so there's probably about 5 marks. Did you get the up-down bit? Yeah. Did you get the left-right bit? Yeah. There's this horrible bit about the minimum point. How many marks are it worth? 1. It's not the end of the world if you don't get that. You know, don't stress yourself out. Bit of trapezium rule. We did this very, very recently with the Usain Bolt graph. Yeah?
So the Usain Bolt graph was like straight lines then?
It was. You can have it with a curve.
Yeah, they it says estimate.
It does say estimate. That's the key words here. An estimate for the area, and it tells you ordinates just mean split it at these points. So when it says ordinate 0, 0 is already drawn for us. 1 and 2. Well, again, 3 as well. That's already drawn for us. So you literally just draw that, draw this. Shape A is what? Trapezium. Shape B. Trapezium. Shape C. Triangle. You could still use the trapezium rule on it. I mean, what you need to go and do is you need to go and work out what these values are in between them. So this line here is 9. This line here is 8. This line here is, I'm going to read off, I think 5 is it? Yeah, 5. And this line here is 0. There is no line. So you could actually just stick them all into the trapezium formula if you wanted to, just to work them out. It's up to you. Okay? To work out A, I'm going to do, that is a half of the parallel side, so 8 plus 9 times by 1. Okay, so 8 plus 9, half of that is going to be 8.5 times by 1 is still 8.5. Okay, and that'd be meters. Okay, no, it wouldn't because I'm not given what is just x and y coordinates, so it's just going to be units squared because we don't actually know what the units are, so like centimetres squared, metre squared, it could be any of those. If it was like metre per second, though, like a distance time graph, just say it's meters. For B, it's going to be a half of 8 plus 5 times by 1, so that's 13, half 13, 6.5. Yep. Just let me know if I'm not writing. And then for C, again, if I wanted to, I could go and stick in a half of 5 plus 0, but that's still just half base times 5. So a half 5 times 1, which is 2.5 units squared. So then the total must be all those added together. What have we got there? 7, 9, 17 and a half.
Yes.
Okay, so although it's a calculator paper, we've actually not used a calculator at all there. Okay, I could get asked how can I make that more accurate? Any ideas? Cut it into more strips, that's always the answer for that. To make better accuracy, if you did look at this being a trapezium, then it would be joining this in a straight line here. Okay, so basically I'm missing out that bit of area there. Whereas if I go and chop this into like 2 pieces, if I go and chop those into trapeziums, look how much wasted space there is now when I did it into more spaces, like hardly any at all. If I chop them into even more space again, even more accurate again. But they'll tell you what to do it, and you don't need to really worry about that, but it might ask you how can you make it more accurate, and all that is cut it into more pieces. Okay? You alright, Sarah? Everything alright?
I just can't see yours, it's good.
I thought you were giving me a really dirty look. What's he talking about? How would that make it more accurate? Okay, part B we probably can't do, but just having a quick scan of the question, you never know, you might be able to do it, because we should do part A first, really. It says the histogram of the wingspan of parrots in the sanctuary show frequency density is that, wingspan is that. Calculate the estimate for the median wingspan in parrots. Okay, there's a fair bit going on here. What does median mean? Let's start with that. Middle value. Now, the answer is I don't know, because I don't know how many are in there. How can I go and work that out?
The area is.
Go on, I'm really close. Well, you're right, it's to do with the area. The area of this bar is how many people there are. So if I came and read this off, between 10 and 20, there wasn't 0.5 birds between 10 and 20. That's its frequency density. As soon as you see this word here, I would circle it and write down FD equals F over CW, okay, or GW if you're Maddie Skirlock Green. Okay, I'm going to rearrange that to get frequency because I want to know how many people there are. So I'm going to take the divide by CW over to become a times by CW to get frequency on its own. Okay, so from here now on the bars, I'm using this formula, my little cloud there, to work out the number of people in the bars, and I'm just going to write it just inside the number of people. So class width 10 to 20 is a class width of 10 times by 0.5. That tells you there must have been 5 people there, okay, or birds. This one here, 20 to 25 is 5, and then that is what? Is that 0.8? 0.8 times 5? 4, very good, but remember this is a calculator, you can sit this into a calculator if you need to. And then this one is 1 times 5, so just 5. This one here, I think it's 2.8 times 5, 14, someone said then, yeah? This one here, 1.5, is it 1.6, is it? Yeah, so you can't have an odd number, can you? If I'd have 1.5 in the word. So then 8, thank you James. And then last one, 0.3 times 20, is that 6? Yeah?
Yes, but.
Okay, so I need to work out the total, which would be 5, add 4, add 5, add 14, add 8, add 6, which is, let me know. 42, yeah. So who's the median person then? Good. Median is the 21st value. Okay, so we've got to find where the 21st value is. This bit's the hard bit, okay? We're probably looking at least 2, if not pushing 3 for what we've done so far. Okay, so 21st value. First 5 are in here. The first 9 are now up to here, on this end point here. The first 14 are now up to here. So I need to be 7 into this category. Now that splits that quite nicely, because the whole bar is 14. So I would have said that that's going to split it into 7 and 7 if I chop it in half. Agreed? Mm-hmm. So if I chop it in half, I just need to work out where it's going to be in that sort of category there. If that's 35, and that's 30, what's bang in the middle? 32 and a half. Well done. It's a hard idea, that one. It was very strange, no matter what it was. All good? Centimetres, very good. Okay, good. I'm pleased with that. I thought people would find that much harder. Okay, the table shows the wingspan of birds in a local bird sanctuary. Thank you. Frequency density column there not filled in for us. So, as soon as you see frequency density, write down your formula. Now, if I were you, I would come and add in another column here called class width, group width, midpoint, all the same things. Oh no, midpoint wouldn't be, because it would just say 15, yeah. So we want to know the distance between these. So 10, 10, 5, 5, 15. What's the last one was 20, wasn't it? I didn't mess that up, did I? Yeah, it was 20, yeah. Okay, all good? Is 10. Well spotted, the deliberate mistake. Okay, so from here, we just need to do 18 divided by 10, which that's easy enough. 2.6. That's 6, that one, isn't it? 2.2 and 2. Okay, so you didn't really need to calculate for any of this bit. Complete the frequency density column in the table and draw a histogram for the wingspan. Now we sort of knew that we're probably looking about right here because the top answer we had was 6 and the frequency density went up to 7. If it was like, if we'd only worked out that it was like going up to 2, like why are they going all the way up to 7? So it should be just a case now that you're just drawing that in. So the first bar to 1.8. Is that coming up on mine okay? There. 10 to 20 like that. Okay, and then the next one, 2.6. Here. Now that 31, that's going to go all the way up to 6, so I sort of can go and find that straight away, and when I do line up that, draw my line.
So I never know on these, like, the wingspan, what to do, like, what point to do.
What do you mean? Well, where I'm drawing these lines here?
Yeah, you go down.
Yeah. So basically, I'm just doing it. So you see there, it says between 10 and 20. So one line went up from 10, the other one went up to 20, and then I just straight it off in between there. Okay. This is hideous graph paper. You'll definitely have good one on the actual exam paper. Okay, it's just to do with our photocopies. Then we've got 35, 2. And then finally, this one 15. So that's what my finished one looks like.
That's not green.
Where's the microphone? Okay, all good?
You tend to bring icons, you're so much better. Yeah, this is the future.
Okay, these are the ones we've been struggling on a bit in class. worries.
Hang on, that's not
Give a bit of a head start.
It's not 15.5.
Who did?
Someone.
Tell them. It's not a mistake, isn't it? It's not like they've done it to annoy you. Well, luckily it's gone up in the holidays, no one's really noticed. We can pass it on. Okay, so it says the area of the cross section is 3x squared centimetres squared and the length of the prism is x plus 7. The volume of the prism is 3x cubed plus 2x plus 1. So I know the formula for volume is area of cross section times length is equal to volume, and I've been told what all of those things are. So I'd be putting in 3x squared, the length is x plus 7, and the volume is 3x cubed plus 2x plus 1. Okay? So next thing I'm going to do is expand that out, and I'm going to get 3x cubed plus 21x squared, and then I'm going to start bringing over all of this stuff on this side to get it equal to 0, because in the question it's got it equal to nothing on this side. Okay? So that 3x cubed comes over and becomes minus 3x cubed. That 2x comes over and becomes minus 2x, and that plus 1 comes over and becomes minus 1. Okay? Good news is they cancel, leave me with exactly what I was supposed to get. All good?
Give me 1 second.
No problem.
Yeah, no, I'm just trying to process it.
Sorry.
Very much space, sir.
I know, I thought it was a bit mean on space.
Yeah.
How are we feeling?
Oh, okay. I'll show
What was that? You correct me if I'm wrong, you do have a pair of glasses.
I did what?
It's effort, isn't it, to get them? It is effort, isn't it?
I know slime looks like
Check.
You're orthodontist.
not orthodontist.
I don't think you'll care.
Oh, can you that's so much.
Like Kellen saying, oh, the other class are doing revision from 9 AM till 12 AM.
That's what they told me.
I hope not.
That's what they told me.
Or 9 AM to 12 AM.
Top PM. PM.
PM, I hope. Yes.
PM. Oh, that's why you said I had not.
I thought you missed my sarcasm.
Oh, yeah.
Yeah. That's doing 15 solid hours. Okay then guys, 5, 4, 3, 2 and 1. First part of the exam that we do actually definitely need to use a calculator for. So it says, use the quadratic formula to solve that thing there, giving 2 solutions correct to 2 decimal places. Now, it may not be quite as in your face and telling you what to do in the exam. The fact that it said, found it to 2 decimal places on a calculator paper is telling me to use the quadratic formula, okay? It's not going to be a case that it can factorise easily. I wouldn't have thought. Okay? So, A equals, B equals, C equals. What does A equal?
21.
21. What does B equal?
-2.
Excellent. -2. -1. Okay? Those minuses, incredibly important. Go and look at the front. It will tell you it's minus B plus or minus the square root of B squared minus 4AC all over 2A. Okay? When you put this into your calculator, I would just change the letters for open brackets. Once we'll do a plus, once we'll do a minus, and hopefully you know the shorthand way of doing that into your calculator. Okay, so what's A? Now what's the first one? It's B, isn't it? So B is -2, goes in there, and -2 again. And then we've got an AC, so that goes 21 there and 21 here. And there was just -1. Okay? -2 squared -1 all over 2.
Sir, is it worth simplifying what's in this?
What's that?
Is it worth simplifying what's in the square root? Like,
You can if you want, but if you do it this way, you definitely will get the full marks. If I'm being honest, when I do it normally, when I'm not showing it on the screen, I simplify it myself. But it should always give you, this one will definitely give you the right answer. So when I add the square root, I get the following answer. X equals 0.27. And when I minus it, do you know the shortcut for doing this now so you don't do it all again? If you press replay, if you press this one here on the right, you jump in straight behind the minus bit there. So you can change that instead of having to go through the whole way through the square root and everything. Let's do it. What do we get? Minus 1/8. Minus, yeah. Now, if I wanted to check, I could use the answer key on my calculator. Can I show the whole thing? Yeah, maybe just. So if I put in, using the answer key into that, if I say 21 answer squared minus 2 answer minus 1, press equals, what should I get?
0.
Look at that. So that's another 3 marks I leave the exam knowing I've definitely got. If I've got that with the second one, the other one must have been right as well. There's no chance that one of them could be right and one of them's wrong, unless you rounded it wrong. And then even then, I'll use the answer key. Okay? So it's a nice way of being certain that you're definitely right.
So what answers do you get?
I got 0.27. Try writing it in. I literally just wrote down what's on the screen there. There's nothing I can really do for that. Okay? Just practice writing it in.
You've done
It's fine to make mistakes now, just have a look back at your calculator and it's the time to make them, okay, in revision. Hence, evaluate the volume of the prism, giving your answer correct to 1 decimal place. Okay, so, I know that my answer is either 0.27 or minus 0.18, but one of those answers doesn't make sense. Which one? Why not? You can't have a negative length, it doesn't make any sense. You can't have a negative area. Okay, so we just we ignore the negative one. We're then going to go and use the positive one. Now I've gone back using the replay button. I've gone up and down, and I've found my first answer. So I've gone back to having this is my answer. So when I use this, it will keep my answer as accurate as possible. So to work out the volume of it, I need to do the area. So that's going to be 3 x squared. So that's going to be answer squared, multiplied by answer plus 7, and that will give me what the volume of the entire thing is. Okay, so 3 answer squared plus answer plus 7.
Sorry, sir.
What's going on? Stop that. 7.49, so that's going to become 7.5 to 1 decimal place centimetres cubed.
Hang on, could we go back?
So without doing that exact, just write 3 answer squared.
It's a good question. I sort of realised I was writing it down just after I'd written it down. Really, you probably should be putting that in like as 3 0.27 squared times 0.27.
Yeah,
It's a good question, James. I'd do that just to be safe in the exam, okay? Give you the same answer.
2h, shouldn't it be 42?
Yeah.
What's that, sorry?
Shouldn't it be over
I've got
42?
different answers than you.
Yeah, same.
Because it's 2
You
times
got it.
8.
Ah, 2.8. Let's have a look. Did I mess it up in my thing? Right, I've written down, I've missed the 2a there.
Oh, it's right hand
Okay,
side,
but if you come and look at my display on my calculator, you can see I have got the 2 there. So well done, it's well spotted there, but yeah, luckily I put it in.
I've got different answers.
You've done something wrong in your calculator. Okay, you need to have a look through. If you can't find it, I'll come and have a look in a moment.
The calculator's broken. I didn't put brackets in, will that affect anything?
Yeah.
It can do, it depends when and where. If you change every letter to open brackets like I did, it cannot possibly go wrong. That's the one thing you need to remember. If you just do that, it's a very repetitive thing to just get into then.
So when I see the answer, you get
Yeah.
So what should I do?
Oh, I don't know, you'll have to have a go at putting it in again. Okay, see if you can put it in again. If you get the same answer wrong again, come and have a look. It's probably just in case you accidentally pressed the wrong key.
I got the same answers now, see, I just put brackets.
All good? That's sorted out. It's the fact that you've got the -1 is the thing that's probably going to make the issue there.
Yeah.
If you don't put the brackets in, it'll give it a positive number. Okay?
So same answer.
Right, I'll come and have a look. You're putting it in a weird way, I can see from here. Put it in the way I've put it in. Oh, right, there. Yeah. Yeah, I don't really quite give you such a difference between them because I'm getting like 7.5 and you're only getting that. Oh, time. Maybe it's that. Oh, no, I don't know. Very strange.
So, you know if teachers don't have like their shirts tucked in?
Yeah.
Do they get a pink slip?
What? Do I get a pink set?
Yeah, teachers don't have their shirt tucked in.
Why did we get a pink set? I certainly have a conversation with the head. He'd probably say to me, he said, look, what on earth are you doing turning up? I've had to tell like members of my old school, spotting up their appearance. It's a mess. It's not a very good role model to you, is it? Oh, okay, right. I've just got to put it in again into my calculator, and I've got that answer.
Just put it on the answer. Oh, this is loading.
Yeah, so I think you're right, Manny. Well done for checking that. I don't know what I was doing before, but I should have had 1.6 to 1 dp. Okay, well spotted.
I wouldn't count that as words.
Okay, give you a little head start on 16. You should be able to have a good go at that. Bear in mind it goes into calculator to begin with.
Stop zooming. I'm not zooming.
Was it when I go home? Was it when I go outside? I couldn't remember. I know this. Yeah.
Yeah.
Oh, is that it?
Oh no, it's on the system vision on the screen. Yeah, that was 500.
You should get that as your answer. They've done it on purpose to be a number that's come up on a calculator that I've then got to put into standard form, okay? So to two significant figures would be... No, stick it in just numbers first of all, because you'll definitely get a mark for working it out in two significant figures. I know it says in standard form, but you'll definitely get one of your 2 marks. So then I've got what? 1, 2, 3, 4, 5, 6, 7, 8 zeros to write.
How many zeros?
I counted 8 then. There's 6 originally, but then obviously these 2 were changed to zeros, so I rounded.
Okay.
So then 8 zeros, is it then the power of 8 that goes here because I've got 8 zeros?
Shouldn't it be 9?
No.
Good, it is 9. It's the number of jumps where that decimal goes in between, which is 1 more than the number of zeros because of the 5. Okay? A stack of 500 sheets of paper has a thickness of 4.8 centimetres. Calculate the thickness of 1 sheet of paper in millimetres. Well, should we turn that into millimetres first?
Yes.
48 millimetres. So then what calculation would I do to try and work it out? What is 1?
Division.
48 millimetres divided by 500 would give me how much in 1? which is 0.096. Again, write it not in standard form first. Okay, so that is 9.6 times 10 to the power minus 2. All good? Well, I can see right angle triangle after right angle triangle angle, so what am I going to use here? It's going to be SOHCAHTOA, isn't it? It's just going to be a number of SOHCAHTOA questions.
Sorry. Yeah, okay.
So top tip there, write your answer first, then write in standard form, because if you mess up your standard form bit, you won't lose both marks. You'll still get 1 for getting each of those answers first. Okay, so we're going to use SOHCAHTOA here repeatedly. So to work it out, we already know what this base is here, don't we? Know that's 15. We need to know what this is, which we don't know. Just E to C. I'll leave you have a little bit of a go from there. If you want to look at any stage, just look up at the screen. I'm starting to solve it, okay?
Oh, why is it giving you? Why does it say 6 marks for that?
It's actually 8 the first time this was released. They changed the marks slightly. It was 8 the first time I saw this.
8. It's just basically. What did you do? Work up this. Shut up. Work up that side and work up this side. Yeah, that works all. Shut the front door.
A bit too loud. You focus on the question.
That's big. It will be YouTube. Don't watch it.
Another one that gets one.
It's almost like compulsory cruel at this point.
So you can probably all go next to you.
Cameron, I'm going to ask you to leave if you can't control the mate.
Just stop taking the calculator. doing this, and then just take my calculator away, and then press it off. Silly.
I was writing it properly. Look, I've done all mine.
What'd you say? 33? Yeah, yes. Yeah.
Just you as like sign out instantly think about sign.
I'd say
Okay, we'll stop for lunch in 15 minutes.
How long is lunch?
Hour, 45 minutes now. Well, I'm going to run out, get food somewhere, and then I'll be back, and then back in. Huh? We'll finish off this paper. Then if people want to go, they can go. I can go over some questions you probably want to see before from the Unitize that are similar to the stuff that we have, and you can just practice those.
Do we do it?
Of course you can, yeah. You might find they're doing exactly the same papers over. Okay then guys, 5, 4, 3, 2 and 1, thank you. Okay, so key thing here.
Well, before I do that, massive Sorry, sir.
Thank you. So we're told that they're similar meaning. That means scale factors, very good. Angles will be the same. That's what these dashes here and here mean. It means they're the same. They're not even rotating them around. So there's nothing too nasty going on here. So we can start off by finding the scale factor. How do you work out the scale factor? In fact, actually, I'm not going to write SF. I was about to write SF, but I'm going to change what I'm writing to scale factor. QWC. Just write the words properly, okay? Scale factor is equal to 24.5 divided by 7 because it's what we call corresponding sides are given. So 24.5 divided by 7 is 3.5. Okay, so just giving a sort of like a note here, say corresponding sides. So small triangle multiplied by 3.5 equals big triangle.
Sorry, so could you move it up?
Of course can, yeah. Okay. So that means that 9 multiplied by 3.5 will equal what x was. So that equals whatever it is. 31.5, thank you. That'll be centimetres. Make sure you include centimetres, it's QWC. You've got to get pounds, and if it's pounds, centimetres if it's centimetres. And then to find out y, it's going to be 15.4 divided by 3.5 is equal to y. Any help? 1.4. Again, centimetres equals y. How much? 4.4. There you go. Now, in terms of QWC, I don't really know what else I can write there. There's not a huge amount I can do there. I think it's so 2 of them are for QWC, 4 of them for the maths. I've said how I've worked that out. I've said what that is. As far as I'm concerned, there's not much else I can write there. Okay. This looks nasty because it's an awful lot of text. Upper and lower bounds, how can I already tell that without really reading this question too far? Like I said, good. Nearest millimetre is actually what told it to be there, but well done people who've gone on and found the greatest possible there. Okay, so time to read the question properly. Right, they're trying to sneak us. They're saying height in meters measured to the nearest 10 centimeters. So we need to have them both in the same units of measure. 4 centimeters to the nearest millimeter. Okay, I'm going to change them to whatever that is. I want that in that measure as well. So I'm going to have that as 40 millimeters. And this 3 meters here, I'm going to have in centimeters. So it's 300 centimeters. Now, when it says correct the nearest 10 centimeters, what you do is you halve that to get 5. And for your upper bound, you add it on. So you'd have 305 centimeters. And for your lower bound, you take it away. Okay? The first bit. For the other bit, nearest millimeter is 1 millimeter. So that's going to then be 0.5 millimeters. So my upper bound and lower bound are 40.5 millimeters and 39.5 millimeters. Okay. Now, again, I've got into a small issue here. It says find the greatest number of these plates that could be stacked in the container. Anyone think they spotted what a mistake is or something to be wary of? I didn't need to do lower bounds. Well, I might have actually. I'm going to leave it for there for now. I'll come back to that bit. But good point. I might not need some of the calculations I've worked out.
What's the question?
It says find the greatest number possible of these plates that could be stacked in the container.
Do you want to make them like all the same measurement?
Good. They've got to be in the same units of measure. I've got centimeters and millimeters. So let's change. I reckon millimeters and centimeters would be my preference. Yeah.
You're right.
So I'd say 4.05 centimeters, and this is 3.95 centimeters. Okay. Now, this is where people get really stuck with upper and lower bounds. You've got to use a bit of logic here. So if I've got a container that is, say, 3 meters long, and I want to fit in these plates, they're just going to take up like stacks of that, aren't they? Yeah. Now, I know how much each of those ones take up. I need to try and work out what is my best case scenario for me to fill in the greatest number of plates I can fill in. So the best case scenario for me is when I've got this thing measured to bigger than I actually thought it was. It's actually at its upper bounds. Yeah? And the plates aren't actually quite as big as I thought they were, meaning I can fit in more. So I actually want the lower bound of the plate. So the calculation I need to do is 305, so greatest possible, is going to be equal to 305 centimeters divided by 3.95 centimeters. Okay?
Yes, I thought. Yeah.
305 divided by 3.95 comes to 77.215 blah blah blah. Okay, so that's telling me 77 and a bit plates. So how many can I fit in? 77 plates. Okay, so not a huge amount of room here. Okay. What if that had been 77.5? Still 77, even though it would have rounded up. You're saying, look, I can fit in 77 and a half plates, but you can fit in 77 then. You can't fit in 78. Okay? If I went and did the other measurements, if I did it as 295 over 4.05, you get 72.8, so I can fit in 5 less plates if it's the other way around, okay? All good?
That's not the next question.
Oh, is it really?
Yeah.
Okay, is it always possible to stack 73 of these plates in the container? No, just worked it out, okay? So that's a coincidence. So, worst case,
scenario.
now as I can't spell scenario, I'm just going to say worst case,
Oh.
would be the smallest container divided by the biggest plate. So that is 295 divided by 4.05, which is equal to 72.839 blah blah blah, but that isn't 73 round to the nearest whole. Okay? So 72 and 0.839 blah 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 of a plate is not 73 plates. Okay? All good? So going back to, I think Laura Jane, you said up here, you said, oh, you might have found bits that you didn't need to find. I always find it's useful to find the upper and lower bound first time round of each, because it may well come in part B. Okay? One more question, then we'll have lunch.
Should we just get our lunch now?
Yeah, sure.
24 sheep. Each different one.
Should have an reasonably easy job after lunch. Finish this paper off.
Calculate the mean number of birds per sheep in your grams. 24.
Okay then. Nice and quiet, please. Thank you very much. Okay, it says 24 sheep gave birth to 1, 2 or 3 lambs. The proportions of the sheep that gave birth to 1, 2 or 3 lambs is shown in the pie chart below. Calculate the mean number of lambs born per sheep. Give your answer correct. Okay, that's quite nice. So mean is add them all together, divide by how many there were. So first of all, we know that there are 24 sheep. So 24 in total. So eventually we'll be dividing by 24, won't we? Okay? So 24 in total. So 120 out of, so 120 degrees out of 360 multiplied by 1 gives me 12 lambs. What am I talking about here? I'm talking a load of rubbish here. Hang on. What am I doing here? Am I doing the right thing here?
Electrons.
24 sheep. So there's 24 in total, isn't it? Sorry, it is 120 out of 360 of 24. So I then times that by 24, the total sheep. But then I times that by 1 because they had 1 lamb. So I didn't quite need to go and cross that out the way I did. So I make that as 8 lambs.
Yeah.
Okay. So how would I go and work out how many had 2 lambs?
Do the same.
Do the same. 150 out of 360 of the 24 lambs in total. Because it's a fraction of how many. There's 24 sheep in total, and we're saying 120 out of the 360 of those 24 had 1 lamb. There'll probably be more lambs in total altogether. It didn't work the first one because I was saying it's 120 out of 360 of 1, and it's of 1 is of the 24 in total. In the entire, there's 24 sheep in here, aren't there? Okay, and then that would be times by 2, and that would probably make sense, wouldn't it? Well, to me, I'd assume that lambs aren't defined to having 1 lamb each. That's it. You'd assume that they're going to grow in number over time, wouldn't you? Okay. How much is that? 20, is it?
Yeah.
24 lambs. Average can't be 1 then because we're already above 24. And then how many lambs, what proportion of lambs had 3 lambs, or what proportion of sheep had 3 lambs?
90 degrees.
90 degrees out of 360 of the 24 times by 3. So that's 18?
Yeah.
So a total of 46? Yeah? So then the mean would equal 46 divided by 24, which is equal to just shy of 2, isn't it? 1.9 something?
You can't have 1.9 of a sheep.
Very good point. You can't. So, in terms of what you round to, I would actually round that to 1.9. Okay? Now, I agree with what David's saying, that you cannot actually have 0.9 of a sheep. But if you look back, there's a famous show that's out, this is when I was a kid though, so it was a long time ago, called 2.4 Children. And the reason why it's called that was the average amount of children per couple was 2.4 in the entire UK. Now obviously you can't have 0.4 of a chance, can you? Aware of that. But 1 dp is good accuracy.
So all I did was I looked at it. I saw that 2 had a greatest part of the pie.
Now in terms of, thank you. In terms of choosing 2 lambs, I'd be round to the nearest whole number or to the nearest integer. Okay? So I could say that instead if I wanted to, and then say this makes more sense because, but when we're talking about averages, it's stupid to pick out the mean average when we look at stuff where you could get 0.9 of a lambs. It doesn't make sense, so it's best to pick a median or a mode or something like that. Okay? Right then.